All right, here's one more additional way we can prove two triangles are congruent, and it is angle, side, angle. Notice the order of the letters. The S is between the two A's. In your triangle, it means exactly that. It means you have two angles and the included side, the side between those two angles, being congruent to two angles and the side between those two angles in another triangle. Thus the order ASA, angle, angle, and a side between them. This is the angle, side, angle postulate, and it says, once again, if two angles and the included side of one triangle are congruent to two angles and the included side of another triangle, we can automatically say that those two triangles are congruent. We need no other information. And here is our last way we can prove triangles are congruent, AAS. Now notice it's similar to our last property, but the difference is the order of the letters. Here the S was between the two A's, and here the S is coming after the two A's. It is not in between them. So that changes our picture. Now we have an angle, and a side not between the two angles, congruent to an angle, and a side that's not between the two angles, which is why we say angle, angle, side instead of... Okay, what is the most obvious way to prove that these two triangles are congruent? So again, we have options now as we've gone through the lesson. We could use SSS as an option, SAS is an option, ASA is an option, and now AAS. So these are our two new properties, but these two we had before in our notes. Which of these is most obvious? Well, SSS requires 3 pairs of congruent sides, and we only have 1. So there's no way it's that. SAS still requires 2 S's. We don't have that. Okay? ASA, now just without doing anything else in the picture, we do have 2 angles, which is what we need, but notice the S, or the side, needs to be between those 2 angles, so it would need to be this side if we wanted to use ASA on this picture. See, again, here we have our 2 angles, and we would need the side between those 2 angles and not this one over here. So the most obvious way to prove these two triangles are congruent is by AAS. We have 2 angles and a side not included between them. Okay, so the most obvious way to prove these are congruent is by AAS. With that being said, how could we use ASA to prove this? AAS is more obvious, but you really can use ASA to prove these two triangles are congruent. It just takes an extra step. That extra step is, remember that in a triangle, the 3 angles always add up to be 180. So we had a theorem that we used that said, if we know 2 angles in a triangle are congruent to 2 angles in another triangle, the third pair of angles are automatically congruent. I think it was called the third angle theorem. And the reason that happened, again, is because they have to add up to be 180. So if these 2 are set, this number is set also. So how could we use ASA? We could use the third angle theorem, which again says if you have 2 angles in one triangle that are congruent to 2 angles in another triangle, then the third set of angles are congruent. We use the third angle theorem, and once we've done that, then notice we have angle and an angle, and the side between them marked as congruent. An angle, and the side between them marked as congruent. So now, after using the third angle theorem, then you can use ASA. So notice with that picture, both worked. The most obvious one was AAS. However, ASA also works if we added the additional step of using the third angle theorem to prove that third pair of angles were congruent.